Hey everyone, today we want to do further mathematics, and the topic that we are to solve in further mathematics is calculus. And calculus, we have two subtopics, which is integration and differentiation. And today we want to talk more about differentiation, and not just only differentiation, the first principle of differentiation. Now, in solving the first principle of differentiation, on my board there, I've written the steps to be as simple as possible for students, even teachers, to be able to solve differentiation using the first principle. So first, the first principle of differentiation defines the derivative of a function using limits. If y equals to function of x, then the derivative of y with respect to x from first principle is dy dx equals to limit h tends to 0 f bracket x plus h minus fx over h. So what I said now, to some people it might look like I'm saying magic, but while I solve questions, you see how easy it is. So these are the steps of solving first principle of differentiation. Step one, h is introduced as a very small change in x. That's the first step. Step two, f function of x plus h is the new value of the function. Why step 3? Function of x plus h minus function of x is the change in y. Why step 4? Dividing by h gives the rates of change. Why step 5? Taking the limit as h tends to 0, give the exact derivatives. So while I give examples, I'm going to introduce these steps while solving the examples. I said earlier, these are the examples of differentiation using the first row, the first principle of differentiation to solve. So we are to make use of these steps in solving these questions. So from the first step, from our definition, initial definition, y equals to function of x. So fx, function of x equals to x. And from step 1, h is introduced as a very small change in x. So fx, x plus h equals to x plus h. Step 2, function of h, ax plus h is the new value of the function. You can see it here. It's the new value of the function here. Why step 3, function of x plus h minus function of x is change in y. So f x plus minus fx equals to x plus y. And our fx is what? Minus x. Step 4, dividing by h gives the rate of change. So we are going to divide through by h. Divide all by h. Step 5, taking limits. Okay, before that, we are going to factorize. X minus x gives us what? H. So h minus h. And the h over h gives us what? 1. So the derivatives, so taking limits as h equals to 0 gives the exact derivative. So derivatives, that is dy dx of x equals to what? 1. Thank you. That's the answer. The differentiation of y equals to x gives us 1. Our second example, we have to differentiate y equals to 3x. Y equals to 3x. From our definition, y equals to function of x. So function of x equals to 3x. And from our step 1, h is introduced as a very small change in x. So f x plus y equals to 3x plus y, because h is introduced as a very small change in x. Step 2, fx, function of x plus h is the new value of the function. X is the new value of the function. Step 3. So from here, before we get to step 3, we want to expand these brackets, which is fx plus h, 3 times x, 3x, plus 3 times h, 3h. So fx plus h, for so step 3, fx plus h minus fx, x plus h minus function of x equals to 3x plus 3y, 3h minus 3x, which is the function of x. So step 4, we have to divide both sides by h. True. Divide through by h. Divide through by h. So we have to collect like times. 3x minus 3x, that is 0. So we have 3h divided by h. So division, h divided by h gives us 3. So differentiation, so the derivatives now, dy dx of 3x gives us 3. That's the final answer. Question we have here is y equals to x squared. Like we said from the definition of differentiation, y equals to the function of x. So function of x equals to x squared. And like we said, h is introduced as a very small change in x. So fx plus h equals to x plus h, all in brackets raised to power 2. Like we have square here, x plus h squared, we have to expand x plus h brackets raised to power 2. So we have x plus h, x plus h. So we have to expand x plus x plus x times x, s squared, plus x times h, sh, plus x, h times x, plus xh also, h times h, plus h squared. So this function of x plus h. So we have this x squared, xh plus xh give us 2xh plus h squared. So the next step, we have to subtract function of x from function of x plus h. So f x plus h minus function of x equals to what? X squared. After we expand it, x squared plus 2hx plus h squared minus the function of x, which is what? X squared. X squared. So we want to collect like times. X squared, s squared minus s squared give us what? 0. So we have 2xh plus h what? Square. So then we are going to introduce step 4. Dividing by h gives the rate of change. So we are going to divide through by what? H. So we are going to collect like we are going to factorize. So h is common here, which will give us what? H bracket 2x plus h divided by h. So this we divide this. So we have 2x plus h So like we said that from our definition, limit h tends to 0. So anywhere we see h will give us 0 here. So we have h here which that tends to 0. So our final answer here give us what? 2x. So dy dx equals to 2x. That's our final answer. And I would like you to subscribe on my YouTube channel and like. Thank you. See you next time. Bye.